Welcome to section 2.5. We're going to look at different ways to take the derivative just based on what kind of functions we're going to interact with. So our goal is to find the first derivatives using basic properties. There are different ways that you might see the derivative actually represented. So the first one is f prime. We saw that last time. Since f of x is representing y, we might also see y prime. And then another way is dy dx. So we're taking the derivative of y with respect to x. These all mean take the derivative. They all mean find the first derivative. So here's some theorems we have. If y equals f of x is a constant, then the derivative is 0. 2, if our function is a power function, x to the n power, and being a real number, then our derivative, here's our first one, our power rule, the derivative, we take the exponent and bring it down front, and then subtract 1 off of the exponent. And you can see that represented there with n times x raised to the n minus 1. Next we have, if we have a constant times our function, then the derivative of our function is a constant times our derivative. If our function can be like broken up into two functions, u of x plus v of x, then the derivative, we can take each one of those individually, u prime plus v prime. Okay, so let's do some, because the best way to understand definitions and properties is by doing. In problems 1 through 6, find the indicated derivatives. So we want y prime when y equals x to the 5th. So we're going to use the power rule. We've got y prime. What we're going to do is bring that 5 down, so we have 5x. Then we have to subtract 1 from the exponent. 5 minus 4, no, getting ahead of myself, 5 minus 1. So now we've got 5x to the 4th. There we go. Find dy dx for y equals 1 over x to the 4th. So we can rewrite this one, so that way it can use our power rule. So I'm going to rewrite this as x to the negative 4th power. And if you need to review exponent properties to understand that when I have an exponent down in the denominator, I can move it up to the numerator and flip the sign, go and get a refresher on your exponent properties, because you want to be fluent in your exponent properties for all of the things we're going to be doing in this class. Okay, we're taking the derivative, dy dx, the derivative of y with respect to x, and I bring down the negative 4, and then I subtract 1 from the exponent. So this is going to leave us with negative 4x to the negative 5. Now I don't want to leave it with the negative exponent, so I'm going to rewrite 4 over x to the 5th. That way it's a positive exponent. That's just one of those preferred things. I don't like leaving negative exponents in my final answer. Next, we want to take the derivative with respect to u of 2u squared minus 3u plus 8. So we're going to use two properties. We can break each one up and take the derivative separately, which was, I think, theorem 4. And we'll use, looks like power rule and constant rule. So we're using all the rules. derivative with respect to u. So first let's look at 2u squared. So we're gonna bring the 2 down, and we still have 2u, and we have 2 minus 1. Minus 3u, so that's going to just leave us with 3. And the derivative of a constant is just 0. Derivative of 8 is 0. So this brings us to 4u to the 2 minus 1. Oh, u to the 1 is just u. Minus 3. And I suppose this one I didn't really explain. I'm going to go back up to our properties in case someone has a question on it. Right here, number 3. So if we have a constant times our function, we have the constant times the derivative, and the derivative of u is 1. So that's where our 3 came from. All right, number 4. F prime, if f of x equals x to the 3.8 plus 6x to the 1.2 minus 8x plus 2. So we're finding f prime. Bring down the exponent, x 3.8 minus 1. Then we have 1.2 times 6x, 1.2 minus 1. The derivative of 8x is 8, and the derivative of 2 is 0. So we have 3.8x to the 2.8 plus, now we have 6 times 1.2, so we've got 2, 6, 7, and then x to the 0.2 and minus 8. Derivative with respect to x of 1 over x to the 4th plus 6 square root x minus 5x plus 8. So we'll take the derivative of each one separately. Actually, let's rewrite first. Let's rewrite a lot of them. 1 over x to the 4th. That gives us x to the negative 4th. Then we have 6 times the square root of x, which is 6x square root of x. Using exponent properties, we can rewrite as x to the 1/2 power. Again, I can't stress enough, you need to really have a good grasp on your exponent properties. Minus 5x plus 8. Now we can take each one. So power rule, negative 4x to the negative 4 minus 1. 1/2 times 6x to the 1/2 minus 1. 5, 0. All right, so we've got negative 4x to the negative 5 plus 3x to the negative 1/2 minus 5. Now we can rewrite everything so we don't have negative exponents. Negative 4 over x to the 5th, it becomes positive, plus 3 over, so the 1/2 becomes positive, but 1/2 means it's the square root, minus 5. All right. Now, one thing that I kind of skipped over is the negative exponent is only on the variable. The 4 does not have a negative exponent on it, so it does not go to the denominator. Same thing over here. The variable x has the negative exponent, so it goes to the denominator. 3 does not have a negative exponent, so it stays. All right, find f prime of x if f of x equals x to the 7/5 plus 3x to the 4/5 minus 3x to the negative 2/5 minus 8. All right. It doesn't look like we have to rewrite anything, so we can just jump right in here. F prime of x, bring the power down, 7 over 5, x to the 7/5 minus 1, plus 4/5 times 3x to the 4/5 minus 1, minus negative 2/5 times 3x to the negative 2/5 minus 1, minus derivative of 8, 0. Okay, power rule on all of these guys. So we've got 7/5 x, 7/5 minus 1, we can rewrite that as 7/5 minus 5/5, and 7 minus 5 leaves us with 2/5. 4/5 times 3, 4 times 3 is 12/5 x, and 4/5 minus 1, 4/5 minus 5/5 leaves us with a negative 1/5. Okay, make sure you're careful with your fraction subtraction. Then we have minus minus, so I'm just going to put a plus. 2/5 times 3, 6/5 x, negative 2/5 minus 1, negative 2/5 minus 5/5. Negative 2 and negative 5 is a negative 7/5 minus 0. And we can rewrite them depending on what your homework asks. If they don't want any more negative exponents, make sure that you rewrite. If it doesn't mention it, then you can leave it like this. Okay, given the function f of x equals 7x squared minus 9x plus 2, find f prime, find the slope of f at x equals 3, find the equation of the tangent line at x equals 3, and find the value of x where the tangent is horizontal. Okay, so we're looking at some specific areas of this graph. Let's start with A. We want f prime. So we'll start with bringing down that 2 times 7x, 2 minus 1, minus derivative of 9x is 9, and derivative of 2 is 0. So we've got 14x minus 9. That's our derivative. Next, we want to find the slope of the graph of f at x equals 3. Well, when you're finding your derivative, that's what we're finding, and we looked specifically at that last time. We broke down what it means to find the derivative, and really it's finding that instantaneous slope. So we will plug in f prime of 3, which gives us 14 times 3 minus 9. And so our slope is 33 at x equals 3. Now we want to find the equation of the tangent line at x equals 3. So what we're going to do is we're going to need our x and y value at this point. So the first thing I'm going to find is, I know x is 3, but I need to know what y is. So I'm going to plug x into the equation. 7 times 3 squared minus 9 times 3 plus 2. And so we're going to get 7 times 9 minus 27 plus 2. We are going to get 38. So we have our x, we have our y, and we have our slope. So since we have a point and a slope, I'm going to use point slope form to find this equation. Y minus y1 equals m times x minus x1. So I've got y minus 38 equals 33 times x minus 3. And we'll just rewrite this into slope-intercept. Y equals 33x minus 61. Okay, and the last one, the tangent is horizontal, and you can think of that if we have something doing this, then the point on the very tippy top has a tangent line that's completely horizontal. So we're finding where is the x value for that one. So if we were looking on the graph, where would it hit the x where it's making that tangent line a horizontal line hitting our graph? Where is that happening? Let's find out. So what I'm going to do is I'm going to start with the slope equation, my derivative, 14x minus 9. And if we look at the slope of this horizontal line, let me make a better one. The slope of a horizontal line, that one's kind of slanting up, but I meant it to be completely horizontal, is going to be 0. So we're going to have 14x minus 9 equals 0. The slope has to be 0. Now we can solve for x. Add 9. Add 9. (14x) equals 9. And so x equals 9 over 14. I'm gonna actually approximately 0.64. Okay, in problems 8 and 9, use the following information for both problems. If an object moves along the y-axis, marked in feet, so that its position at time x in seconds is given by the indicated function, find the instantaneous velocity, the f prime, find the velocity when x equals 0 and x equals 4, and the times when our velocity v is 0. Okay, let's start with A. We want the instantaneous velocity, our f prime. So we have f of x equals 5x squared minus 3x plus 6. So let's find f prime. Take our first derivative. So 5 times 2, 10x. Derivative of 3x is 3, and derivative of 6 is 0. So f prime, or what they are calling v equals 10x minus 3. Part B. Now we want to know the velocity when x equals 0 and the velocity when x equals 4. So we're going to find v of 0, which is 10 times 0 minus 3. That's going to give us negative 3. And we want v of 4. So 10 times 4 minus 3. So we've got 40 minus 3, which is 37. And then we want to know the time or times when the velocity is 0. So when our velocity is 0 is when 10x minus 3 is 0. So let's find our x, our time. So we'll add 3, 10x equals 3, x equals 3 tenths. So at 3 tenths of a second. All right, and they said there was a second one that we wanted, and we need to answer the same questions. So first we want f prime. So the derivative of x cubed is 3x. We subtract 1, it leaves us with a 2. 21 over 2x squared. So we bring down the 2, then we have 21x minus 1 is just a 1. Derivative of 3x is 3. Okay, and they are calling this v. 3x squared minus 21x plus 3. Okay, now we want v of 0. 3 times 0 squared minus 21 times 0 plus 3. So this is going to leave 3. And then v of 4. 3 times 4 squared minus 21 times 4 plus 3. So we've got 4 times 4 is 16, and 16 times 3, 21 times 4 plus 3. So we've got negative 80, 40, negative 84, positive 48, positive 3. So 3, 3, negative. I hope. Okay, C, we're looking at when is our velocity 0? 3x squared minus 21x plus 3. When that is 0, well, let's pull out a 3. X squared minus 7x plus 1. I'm wondering if they meant for this to be 30 instead of a 3. Oh well, we'll just work with this. Okay, so we can't factor, so what we're gonna do is I'm gonna plug it into the quadratic formula. And if we refresh, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is a 7 plus or minus the square root negative 7 squared minus 4. A is a 1, c is a 1, all over 2. A is a 1. Okay. So we've got 7 plus or minus 49 minus 4 over 2. 7 plus or minus 45 over 2. 45. 9, 5, so 7 plus or minus 3 root 5 over 2. That's where I'm going to leave it. So we have x equals 7 plus 3 root 5 over 2 and 7 minus 3 root 5 over 2. You could throw this through your calculator and get a better estimate, but that's what we wanted. And I feel like if this had been 30x, we would have come out with nice clean numbers, but we made do with what we have. Okay, find f prime of x if f of x equals 5x minus 6 squared. So let's figure out first of all what this, let's rewrite it. So if I have 5x minus 6 squared, I've got 5x minus 6 times 5x minus 6. So I've got 25x squared, 5 times 6 minus 60x, 6 times 6, 36. Okay, now that we have this all written out, we can find f prime, just working one at a time. F prime of x. So 25x squared, we bring down to 2. 25 times 2 is 50x. 2 minus 1 is 1. Derivative of 60x is 60. Derivative of 36 is 0. All right, one more. F prime if f of x equals 8x minus 7 over x. So I am going to rewrite this. F of x, 8x minus 7 over x. I'm going to break it into two fractions, 8x over x minus 7 over x. And that even at 8x over x is 8. 7 over x is 7x to the negative 1. Remember those exponents. Well, this is a lot more feasible to find f prime. I mean, we can, later we'll figure out how to do rational functions like that, but right now, just using the properties we know, we want to rewrite it. Derivative of 8 is 0. Then negative 7, bring down a negative 1. So negative 7 times negative 1 is 7x. Negative 1 minus 1 gives us 7x to the negative 2. And so we'll rewrite that 7 over x squared. That's our derivative.